Hello everyone, my name is Protasilaos, also known as Prot. In this video I want to talk to you about regular expressions inside of Emacs. I have prepared the tutorial with some tangible examples for you to get started with the basics of regexp notation. Of course, Emacs is a very powerful interactive editor and you don't really need to know any kind of regular expression syntax for you to be productive. You can rely on the packages, on the functions that are either built into Emacs or are provided by third parties for you to effectively perform surgery on text. For example, you can use multiple cursors, edit, you can use the built-in occur and various other tools to be very productive. You don't really need regular expressions. However, knowledge of regular expressions can definitely take you one step further, can make you a better user of Emacs and also much more efficient when it comes to your work, especially at scale, especially when you are recording keyboard macros. These two go together, macros and scale. The larger the scale, the better off you are using a keyboard macro, and this is where regular expressions can also come in very handy indeed. Before I proceed with the presentation, this is the very first thing you need to do. Do I have screen key running? Okay, you can see my key presses. This is the very first thing you need to do. Control HR followed by the letter I will prompt you for a topic in the index of info pages. So the official manual, you want to search in the official manual in this case for regexp. This thing over here, you hit the return key and it will take you to the chapter in the manual that concerns the syntax of regular expressions. This is essential reading. You must definitely go through this if you are to make any use of regular expressions. It covers everything, and some of these I will also present them in my demo that will follow in a second. Then you must also definitely read, of course you should read the whole manual, the entirety of it, but you should at least also read the chapter about the backslash in regular expressions and what is the meaning of it and how it affects all these constructs. Again, I will show some of these in my demo with the proviso, with the understanding that what I am about to show is not exhaustive. It will not make you an expert in regular expressions. This is just an introduction, perhaps to inspire you to test and experiment with things yourself. With these introductory remarks out of the way, let us proceed to the demo. I will keep screen key running so that you can see my key presses as well. Even though these are not always necessary, I think it is a good idea to be able to see a key press in case you don't understand what I am doing. You can refer to screen keys indicator over there and follow along. So, the very first thing you need to learn when it comes to regular expressions is line boundaries, the beginning of the line and the end of the line. The beginning of the line is denoted by the caret sign, this thing over here, whereas the end of the line is denoted by the dollar sign. So in this example over here, it asks us to match lines that start with a space. So it's this line over here and this line over there. You see them? They start with a space. So for this we want to use just standard iSearch. But we wanted to be aware of regular expressions. So we have two options here. Either we will start iSearch and then toggle regular expressions with meta and R, or we will go directly to the regexp aware iSearch, control meta and S, or control meta and R if you are going in the opposite direction. You can see at the lower part of the screen we have regexp iSearch. So now we want to search for what starts with a space. Okay, so you see what it is matching over there. That's very nice indeed. And now we want to match every line over here that ends with a capital S. You see this line ends with a capital S and this one, but we don't want to match, for example, the capital S in the middle of the sentence. We just want the final one, right? So again, we do the regexp I search, and now we want to insert a capital S followed by the dollar sign. Let me do this again, I was clumsy. Capital S followed by the dollar sign, and we see that it is matching exactly those two things over here. So that's very nice indeed. Okay, so now we will make use of these now that we know how to match lines. So it asks us to remove the empty lines. First we want to do that, and then we will proceed to the next part, which asks us to keep the lines that contain the term username. To help us with this demo, I will toggle white space mode. And you can see I have this bound to a key, by the way, but I did the Emacs so that you can see. So the empty lines are denoted by the dollar sign. So the new line character, rather, is denoted by the dollar sign. But you can see on the empty lines that the line effectively starts with the dollar sign, right? So knowing this, we can target these lines specifically. But let's remove the white space mode, and let's select this region. We want to operate on this region specifically. There is a built-in function to remove lines matching a regular expression, so we will use that. Emacs flash lines. Okay? So now it is asking us for a regular expression, and we want to remove the empty lines, we said. So we want lines that start with the dollar sign. Okay? So starting with the dollar sign means to remove the empty lines. So it flashed those lines. Now we want to select this, and we want to keep the lines that contain the term username. Emacs keep lines, and now it is asking us for a regular expression, but in this case we are not using a regular expression, we are just using this string of characters over here, and we want to keep those lines and remove everything else. That's very nice indeed. Let's proceed. The dot character, this is a very special character in regular expressions which will match every character, every letter, every number, every symbol, except for the new line character, except for the dollar sign, right? So in this example, we want to match all these words by using their common string, their common part. So we want to match dired, fired, mired, tired, and wired. Let's use, again, regular expression aware I search. So we will insert the dot. You can see how it is matching everything, right? Followed by ired. So you can see what is being matched over here. So that's very nice indeed. So now that we know about the dot character, let's proceed, and we will start combining things as we go, as we proceed into the demo. Character sets and ranges. When you want to specify a set of characters that you want to target, you have to include it inside of brackets, inside of these things over here. And I have a table here with some ranges of characters. So if you have A-Z, it means every letter from A to Z, every lowercase letter. If you have it like this, A to Z capitals and A to Z lowercase, it means every letter either uppercase or lowercase. So it will match both. This set over here will match every lowercase letter and every number from 0 to 9. 0, 1, 2, 3, all the way to 9. Whereas this set over here, you see it? It will only match A, B, C, D, and then the numbers 1, 2, 3, and 4. So by default, what you have inside of square brackets is understood as a single character, except for when you have a hyphen between them, so it will understand them as a range, provided, of course, they can be understood as a range. So what we have to do in this example over here is we want to match both of these words by targeting their first letter. So it has to be a regular expression aware iSearch, and we want to target the group E capital and E lowercase, and then we want to edit this, and we want it to start with those letters, right? So you see that it is matching this one and the other one. Please ignore the next example, it doesn't really matter. We were able to match both the lowercase e and the uppercase E at the beginning of the sentence. Okay, so now it asks us to match those that end with a number. So let's have a range 0 through 9 and then the $sign. Okay, so we matched the lines that end with a number. Okay, let's proceed and see how it goes. Okay, let's talk about the postfix operators. These are special characters that you use in regular expressions. By themselves, they are not characters. You cannot target them specifically unless you escape them. These operate, the reason they are called postfix is because they will operate on the set that you have right before them, if you have a set, or a character, if you have a character. And they will alter the behavior of this match. So if you have a character, a search term, followed by the question mark, it means to match that search term 0 or 1 times. If you have the plus sign, it means 1 or more times it has to match. And if you have the asterisk, it means 0 or as many times as possible. So let's see this in practice. Here we want to match the S optionally. So we want to match both of these. We use again iSearch and we write day, and then we hit the letter S followed by the question mark. So you see it is matching both of these. In this case, the postfix question mark operates on the letter S. This is the previous character that it is supposed to match. Okay? Now using this common string, prote, we want to check the behavior of all of those 3 postfix operators. So let's write prote, and let's check the postfix operators one at a time. First, the question mark. So you see it is matching prot and then prote like this, as we have it over here. Now let's edit this and let's add the plus sign. The plus sign means 1 or more, so it is not matching prot because prot does not contain the last character, the letter E. It does not contain it 1 time or more, so it is matching this one and the other one at the end. What about the asterisk? So you see the asterisk is matching 0 or as many times as possible. So it is matching everything over here. Okay, that's good. Let's proceed. Grouped matches. So a group, when you want to specify a group of characters, either a string or a set, you have to enclose it in parentheses, but each parenthesis has to be escaped with a backslash. So like this, as it is over here. So you cannot have just standard parentheses because then they will be understood literally. So that would be false. So in this example over here, we will do what we did earlier with the postfix character, the question mark, but we want to match both conf and config. So if I do conf, if I were to do ig like this followed by a question mark, it wouldn't match both of these because the question mark, the postfix, operates on the character G, so that's false. To make it match both of these, I have to make the I and the G a group, like this. So you see it, it's enclosed in parentheses, and each parenthesis has to be escaped. You see how it is? It is preceded by a backslash, and then it's the parenthesis. So like this, you see that it is matching both of these. So that's very nice indeed. Let's proceed. Greedy versus non-greedy. By default, all of these postfix characters are greedy. This means that they will, of course with the exception of the question mark, this means that they will match as much as they can. If you want to make them non-greedy, you have to follow them by the question mark. So I will show you in practice what greedy and non-greedy means in this example over here by using this specific construct over here. What this means now, the dot followed by the postfix, the asterisk. It means every character, then as many times as possible, okay? So let's see this in practice. Hello, and then we have every character as many times as possible, and then world. So you see that it is matching both lines over there, so this is a greedy match. To make this non-greedy, we have, as I said, we have to add the question mark following the postfix character. So you see now it made it non-greedy, so it matches the shortest possible part rather than the longest possible part. Okay, so multiple groups. Match the alphabetic and numeric parts in two separate groups. So as I said, the groups are inside of parentheses, but this time we want to have them as two separate groups. So for this one, to make it easier for our demo, I will use a third-party package called Visual Regexp, and the commands it has are vr and then a /, and these are the commands. I will use the one with query and replace like this to make it easier for our demo. So we want to create a group that contains A to Z, and this contains it as many times as possible, right? So the asterisk. Sorry, I forgot the parentheses. So inside of parentheses, I have the first group. For now, it is matching too many things, but don't worry. And then inside of the second group, I want to have 0 through 9, again, as many times as possible, and I want to close my group over there. So to make this avoid all those false positives, we can start the line with the letter E. Okay, you see what we did over here? So this is a bit more complex. Let's see it again in practice. Start of the line with the letter E. Then we have a group. You can see the parenthesis that is being escaped. And the group contains a set of lowercase a to z. And the asterisk means to match these as many times as possible. And this closes the set. This closes the group that contains this set with as many times as possible. And then there is another group that contains numbers as many times as possible. So the second group is the green one. The first group is the purple one. And the single character at the beginning of the line, you can see it how it is over there. Okay, let's now match a literal hyphen and a literal dot. So we want to have the literal hyphen as part of the alphabetic group, and then the literal dot as part of the numeric group. Let me use regular expressions. Let me use iSearch for this. And let's do A to Z. And then when you want to match a literal hyphen inside of a group like this, it has to be the very last thing inside of the group. Otherwise, it is understood as a range, and this creates problems. It will not be correct. So you can see what I am matching over here. You can see how it is. Again, if I want to match only the lines that start with E, you see how it is, like this, right? And now we want to also have numbers in there, 0 through 9, and then the dot as well, like this. Okay? I could do this as two separate groups by also grouping them in parentheses, but that's not really important right now. It doesn't really matter. You can understand how it works. The point is to be able to also have a literal symbol in there, like the symbols, the special symbols, hyphen and dot. Okay, now we want to exclude the set. When you want to exclude the set, you have to prepend it, you have to start it with the caret sign inside of the brackets, of course. So when you do that, it means that it will match just it will match everything that does not include that set. So what I want to do in this example is I want to match every line except those that start with a capital letter. So this is the condition for doing this. I will use a slightly different technique here. I want to mark this region, and I will use query replace, regular expression aware query replace, control meta and the percentage sign, to match the start of the line and then a set that does not include A and Z. Okay, let's see what is being matched. Let's replace it with whatever, it doesn't matter. I just want the highlight. So to match every line except for the lines that contain capital letters as their first letter. Okay, so that's what we did over here. Nice, let's proceed. Alternative groups with literal brackets. Okay, first we want to match these two using a set. Let's do it with iSearch. So we want to be, you see it's name and then nom, N-O-M. So we want to have N, then A or O. Remember, when we have inside of the brackets, it's always one character at a time, right? So it's either A or O in this case, then followed by M, and then to match both name and no, we have to have the character E followed by the postfix of the question mark. So you see what it is matching? Name and no. Ignore the others, doesn't matter. We were able to match name and no in this example over here, so that's great. And now it wants us to match okay, every line that contains username or variations, so for example this one and this one, to match name and no, including the literal brackets over here. Okay, so first let's run iSearch. We will break this down in several parts. Let's run iSearch first, and let's match the literal brackets. So to match a literal bracket, you have to escape it like this. You see already it is being highlighted. Then let's use the sets. So inside of brackets that have a special meaning this time. You see the syntax already. You see what is being highlighted. Followed by M, followed by E with a question mark, so a postfix, and then another escaped bracket. So you see what I was able to match? Okay, good. So it wants us to replace the match with a prot, but only for the lines that contain username. So not for this line and not for the last line. We don't want these. We want only that one over there. So let's do this and see. Let's use the visual regexp, this one. So we want to have the first group. This is a bit trickier, okay? So let's do it slowly. So the first group has to start with user and then followed by any character. So this is the first group. So already I am able to specify the two lines I am interested in. Then the second group has to be what I wrote earlier with name like this, N-O-M-E, question mark, like this. Okay, and then the third group, very simply, can be just a wildcard, but I want to specify it as a third group. So you can see the different colors. It's very clear what I am matching this way. This is a fantastic tool, by the way, to practice regular expressions. Another tool is the built-in regexp builder or rebuilder. I will just type it out a bit later. So you can see this over here, and now we want to replace only the green part. Okay, we want to replace it with the string prot with capitals. So when we have groups like this, we can specify a group by its number using the backslash. So backslash and the number 1, you can see it is bringing the first group where it was. But I could, for example, change the order, of course. But I won't do that, it doesn't matter. So I want to place the first group where it was. Then for the second group, I just want to have this. And then the third group, also place it where it was. So you can see the result. What would the result be? You can see that I was able to target these groups and specifically inside of the brackets have the capital string, the string in uppercase characters the way I wanted. So I can do a query replace yes, and then I can hit the exclamation mark to replace everything at once. Okay, that's very nice indeed. And this is another example that we have over here, the either match. So we want to target either set of targets, of matches. And we will use again the regexp tool, which is nice. Let's use this. Let's invoke it. And what it wants us to do is first let's match these characters, and then we will see how we go. So it has to be a group, let's have it like this, which has group, and then this column, and then match, like this. Okay, so you see, so this is false, because we only want to match the first instance of these. So group, and then hyphen, and then something. So we will also add the hyphen over there, okay? And it wants us to prepend to this match over here the VR and the forward slash. So when we want to recall what we just matched with the query and the replace, we can use backslash followed by the ampersand. What's it called? Yeah. Anyway, this character over here, shift and the letter, the number 7 on US QWERTY keyboards. So we reference the match again, but this time we want to prepend to it. So like this. You see what we are doing? Okay, so let's do that. Okay, we were able to refactor all these just by matching the group and then referencing that group and prepending some text to it. Okay, nice. And now this is the very last part of my presentation, running eLisp functions on groups. So this is fantastic. I didn't find this in the manual. I'm not sure where I found these, but it's very nice indeed. So when you want to run an eLisp function, you will have to escape it with the comma. So it's backslash, comma, and then the function inside of parentheses. So here we will use what we used earlier with the dot and the ired, the pattern, to run a replace operation, and we want to run the eLisp function uppercase on the second match. Okay, let's take this slowly. So we have the second match over here of each word. It's the same word repeated thrice. And we want this second instance to be turned into uppercase using the corresponding eLisp function. So let's use again query replace, which is easier for the purpose of this demo. We will start a group which is .ired. So this is one group. Of course, now it is matching everything, but if we create a second group, which is exactly the same as the first one, you see now it is matching two groups. And if we create a third one, let's have it like this, it is matching three distinct groups. So what we want to do is we want to replace the green group, not replace, make the green group all uppercase letters, but keep everything else intact. So we recall that we can use backslash and the number to specify a group. Now we will use the specific syntax that we have to run the uppercase function on the second group. You see the syntax over here? You can see it already live. I am very excited about this. This is absolutely fantastic. So you can see exactly what is going on here. This is a preview of the replacement. I haven't done the replacement yet. Match the second group and run an eLisp function on the second group inside of the replacement using regular expressions. So you say, you hit the return key and you press the exclamation mark, and it does what you want it to do. This is absolutely fantastic. I don't recall where I found this, but if I find it, I will definitely add a reference in my .emacs as well. But yeah, that's all for now, folks. This is the presentation. You should definitely practice your regular expressions. You can use the package called, let's say you don't have the package now. You can run package install, and then the package you are interested in is visual regexp. Because I already have it, it is not appearing here, but this is what you want to search for. You definitely want that package, is what I was using here. It's very nice. Or you can use the built-in tool called Emacs regexp builder. This is another tool that contains different types of notation. Once you have this up and running, you can do Ctrl-H-M to get some information of what you can do with this. And it supports different types of escaping / characters, so it can be very useful because there are two different types of notation that you are using. One is when you are doing a query replace, such as what I was doing in this demo, where you just use a single /. But when you want to write eLisp functions, unless I am mistaken, you must always use a double / to denote an escape character. So you can use the regexp builder to test your regular expressions. This is very nice indeed. Let's do an example over here to see what I mean. So you see it has to be a double / and then ired like this. Does it match? Where is it? Okay, let's remove that. Did I do something wrong? Maybe. Okay, screen key is interfering. Okay, I had changed it. So you can do Ctrl-C and Tab to change the syntax style that you need. The default is read, which will require, you see the notation over here, double, screen key is in the way. Okay, so you see the notation over here, double / to escape the parentheses. So whenever you want to escape a special character, you have to use double /, Ctrl-C Tab, and then string will take you to the kind of regular expressions that you use when you do a query and replace, what I was doing in this demo. Anyway, I recommend you also check the regexp builder. It's very powerful, and you can use this to check the various types of regular expressions that you want to use. Definitely study regular expressions, study the manual for them, and run some exercises like the ones I am doing over here. It's very nice to practice your skills. Try to come up with examples. Try to spot patterns in your code if you already have some code. Try to spot patterns in your standard text, even in regular text, and try to perform different kinds of operations on that text. Even if it's prose, it doesn't matter, you can still do a lot with it. Because this will come in very handy when you want to take your skills to the next level. Because now you can combine all this with keyboard macros, you can combine all this with search and replace in multiple buffers through, for example, the built-in multi-occur function and things of that nature. The possibilities are practically endless. You can do whatever you want when you know regular expressions. You can be very precise and very effective and very efficient indeed. That's all for now, folks. I hope these examples offered you a primer, and now you can go on to study things further. Thank you very much for your attention. Have a nice day. Goodbye.